Today's topic is parabola, second lecture. In our last class, we have discussed 4 standard forms of parabola. One is y square is equal to 4ax. Its focus is a comma 0, vertex is 0 comma 0 and directrix is x plus a is equal to 0. And length of the lattice rectum of this parabola is 4a. And equation of the axis is y is equal to 0, that is x axis. Equation of the tangent at vertex is x is equal to 0, that is y axis. And focal distance of a point P x1 y1 is mod x1 plus a. We have discussed all these formulae about y square is equal to 4ax. Similarly, if the parabola is like this with concavity towards left, then the equation of the parabola will be y square is equal to minus 4ax, and you will get all the formulae of corresponding to this parabola replacing a by minus a, except the lattice rectum, because the lattice rectum is the length, its length is 4a. And similarly, we have discussed 2 more forms. If the parabola is like this, its equation is x square is equal to 4ay, and its focus is 0 comma a. Directrix is parallel to x axis. Its equation is y plus a is equal to 0. Length of the lattice rectum is 4a and focal distance of a point x1 comma y1 is mod y1 plus a. You will get all the formulae corresponding to this parabola replacing x by y and y by x, interchanging x and y, and also interchanging the coordinates. A comma 0 becomes 0 comma a. In this way, we have to interchange coordinates of every formula and interchange x and y in every formula. Then you will get the formula of x square is equal to 4ay. And if the parabola is like this, then its equation is x square is equal to minus 4ay, and you will get all formulae of this parabola replacing a by minus a in the formula of the above parabola. Now, if this parabola is shifted to some other position, keeping the x axis parallel to keeping the axis of the parabola parallel to x axis. Suppose I have shifted this parabola to this position like this. This is the new vertex and axis will be parallel to x axis. Axis of the parabola is parallel to x axis. Then if this is h comma k, what we should do is, in the equation you have to replace x by x minus h and y by y minus k. So equation of this parabola will be y minus k whole square is equal to 4a into x minus h, and in the equation we are replacing x by x minus h and y by y minus a, but 0 0 which is vertex has become h comma k. That means for coordinates of a point we have to add h to the x coordinate and k to the y coordinate. So what will be the new focus? What will be the focus of this parabola? This is a comma 0. Adding h and k to the coordinates, this becomes a plus h comma k. In this way, we will get all the properties of this parabola. The focus, vertex, directrix, etc. are called characteristics of the parabola. Now, let us see the characteristics of this parabola. The equation of this parabola, this is the origin. The original parabola is like this. This is shifted to this position. Now, the new vertex is h comma k, and equation of this parabola will be y minus k whole square is equal to 4a into x minus h. What will be the coordinates of the focus in the new position? This focus is a comma 0, so this focus is a plus h comma k. Similarly, in all formulae, if it is a point, we will add h comma k to the coordinates. This vertex is 0 comma 0, adding h and k, new vertex becomes h comma k. Focus of this parabola is a comma 0, adding h and k to the coordinates, we get focus of this parabola as a plus h comma k. Length of the lattice rectum remains same because the same parabola is shifted. So, length of the lattice rectum means this length, it remains same. Equation of the directrix. What is the equation of the directrix of this parabola? In the original position, x plus a is equal to 0. Then replacing x by x minus h, the equation of this parabola, equation of the directrix of this parabola is x minus h plus a is equal to 0. Equation of the axis. In this position, the equation of the axis is y is equal to 0. So, in this position, y minus k is equal to 0. Equation of the tangent at vertex. This tangent at vertex in the original position is y axis, that is x is equal to 0. So, in this position, the equation of the tangent at vertex will be x minus h is equal to 0. Next, focal distance of a point x1, y1. In this position, focal distance is given by mod x1 plus a. So, in this position, it is mod x1 minus h plus a. We have to replace x by x minus h. Okay. Similarly, if you take this parabola, its equation is y square is equal to minus 4ax. Now, I am shifting it to some other position like this, keeping the x axis parallel to the old x axis, keeping the axis of the parabola parallel to the x axis. Now, the new vertex is h comma k. Then we will get all characteristics of this parabola by replacing x by x minus h and y by y minus k if it is an equation, and we have to add h to the x coordinate and k to the y coordinate if it is a point. Now, let us see the characteristics of this parabola. This first one is over. Yeah. Yeah. This parabola is shifted to this position. New vertex is h comma k. Then the other formulae you can see from this list. Vertex is h comma k. Focus. What is the focus of the parabola in this position, in the original position? Minus a comma 0. Then adding h and k to the coordinates minus a plus h comma k. Length of the lattice rectum remains same because the same parabola is shifted. Next, equation of the directrix. Directrix of the parabola in this position is x minus a is equal to 0. Now, x minus h minus a is equal to 0. Equation of the axis is x axis, y is equal to 0 in this position. So, in this position it will be y minus, equation of the axis y minus k is equal to 0. Equation of the tangent at vertex. Here tangent at vertex in the original position is y axis, that is x is equal to 0. Now in this position tangent at vertex will be x minus h is equal to 0, and focal distance of a point x1 y1 in this position mod x1 minus a is the formula. Here mod x1 minus h plus a is minus a is the formula. Here mod x1 minus a, here mod x1 minus h minus a. Similarly, the next standard form is this parabola. This is x square is equal to 4ay. Its focus is 0 comma a. Directrix is x plus its directrix is y plus a is equal to 0. Length of the latus rectum is 4a, and we have discussed all the other characteristics. Now if this parabola is shifted to some other position keeping the axis parallel to y axis, then if the new vertex is h comma k, the equation of this parabola will be given by replacing x by x minus h and y by y minus k. So the transformed equation will be x minus h whole square is equal to 4a into y minus k. This is the equation of this parabola. Okay. Now let us see all the characteristics of this parabola. X minus h whole square is equal to 4a into y minus k if the parabola is like this. What are the characteristics? Vertex h comma k. Focus of this parabola. Focus of the parabola in this position is 0 comma a, and adding h and k to the coordinates, this focus will be h comma a plus k. Okay. Second point, length of the latus rectum is same, size does not change. Equation of the directrix, in this position the directrix is y plus x plus a is equal to 0, y plus a is equal to 0. So equation of the directrix of this parabola will be y minus k plus a is equal to 0. Equation of the axis, equation of the tangent at vertex, all are obtained in the same manner. Focal distance of a point x1 y1, in this position the focal distance is given by the formula mod y1 plus a. We have discussed it in the previous class. Now in this position the focal distance is given by mod y1 minus k plus a. You have to replace y1 by y1 minus k. Similarly, we have discussed one more standard form, that is this downward parabola. Its equation is x square is equal to minus 4ay. What is its focus? 0 comma minus a. Equation of the directrix, y minus a is equal to 0, and the other points we have already discussed. Now if this parabola is shifted to some other position like this, then axis is parallel to y axis. Vertex is h comma k. If the vertex is h comma k, the equation of this parabola will be x minus h whole square is equal to minus 4a into y minus k. Now all the characteristics of this parabola are given in the list. This is the parabola. The characteristics are vertex h comma k, focus h comma minus a plus h, adding h and k to the coordinates, length of the lattice rectum 4a, equation of the directrix y minus k plus a is equal to 0, replacing y by y minus k, equation of the axis, equation of the tangent at vertex, focal distance. If you can remember the list of the characteristics for the first parabola, what is that? Y square is equal to 4ax and y minus k whole square is equal to 4a into x minus h. Then you will be able to write the characteristics of all the other forms, if you remember the method. Okay. Now, some important observations from the above 4 standard forms. If the axis is parallel to x axis, the parabola will be either like this or like this. If it is like this, the equation is in the form of y minus k whole square is equal to 4a into x minus h. If the axis is towards left, the equation of the parabola is y minus k whole square is equal to minus 4a into x minus h. If you simplify this equation, you will get the simplified equation in the form of x is equal to some constant into y square plus some constant into y plus some constant. This a is different, this a is different. Okay. So, we will get the simplified equation in this form, x is equal to a quadratic function of y. Similarly, if you take the other 2 standard forms, what is that? One is upward parabola, another is downward parabola. If it is upward parabola, the standard form is x minus h whole square is equal to 4a into y minus k. If it is downward parabola, the equation of the parabola is x minus h whole square is equal to minus 4a into y minus k. In both the cases, axis of the parabola is parallel to y axis. In these 2 cases, axis is parallel to x axis. If axis is parallel to y axis, the equation will be either in this form or in this form. After simplification, the equation will be reduced to y is equal to ax square plus bx plus c. So, this is the simplest form of the parabola whose axis is parallel to y axis, and this is the simplest form of the parabola whose axis is parallel to x axis. Here you can observe that the concavity of the curve will be upwards if the coefficient of y is positive. Similarly, the concavity of this parabola will be upwards if a is positive, and if a is negative, the concavity will be downwards. So, from the sign of a you can know whether the parabola is upwards or downwards. Similarly, in this case, if a is positive, concavity will be towards right. If a is negative, concavity will be towards left. Instead of telling concavity, we can say that the axis is parallel to positive x axis. Even though the a straight line has no direction and axis is a straight line, we can assume that the direction of the axis is, for this parabola, this is the direction of the axis. For this parabola, this is the direction of the axis. For this parabola, this is the direction of the axis. So, here the axis is parallel to positive x axis. In this case, the axis is parallel to negative x axis. Here the axis is parallel to positive y axis. Here axis is parallel to negative y axis. Okay. Now, let us list out all these important points. The equation of the parabola with axis parallel to x axis is y is equal to ax square plus bx plus c. If a is positive, it is concave upwards. If a is negative, concave downwards, or axis is upwards, axis is downwards. Next point, the equation of the parabola whose axis is parallel to x axis is x is equal to ay square plus by plus c. If a is positive, concavity is towards right. If a is negative, concavity is towards left. And you can also remember that length of the lattice rectum of this parabola or this parabola is 1 by mod a. You can easily derive it. If the parabola is x minus h whole square is equal to 4a into y minus k, length of the lattice rectum is 4a, its axis is upwards. Now, if it is reduced to this, then what will be the length of this lattice rectum? Here a is present in both the equations, so I will take this a as lambda. Then this is the parabola whose shape is like this. Length of the lattice rectum of this parabola is 4 lambda. Okay. Here you can write this as y minus k is equal to x minus h whole square by 4 lambda. Then y is equal to, taking minus k to right side, we get y is equal to this plus k. Now this is same as this. Then comparing coefficients of x square, 1 by 4 lambda is equal to a. So 4 lambda is 1 by a. So length of the lattice rectum of this parabola is 1 by a, but sometimes we may assume that a is negative, that is why 1 by mod a. Next point, standard notation. In this chapter we are going to follow one notation. Instead of writing the long equations, we can write the formula in short forms. We have already seen it in circles. Let us see what is the standard form. Y square minus 4ax. I am talking about the first standard form, y square is equal to 4ax. In proving anything or in deriving any formula, we have to use, or we will use, the standard form y square is equal to 4ax. So first standard form is y square minus 4ax is equal to 0. Instead of writing this equation, you can write s is equal to 0. It represents the same equation, where s is y square minus 4ax. Now, just like circles, S1 is y1 minus 2a into half of this into x plus x1. We have seen the notation in standard circles, x square plus y square plus 2gx plus 2fy plus c. This expression is denoted by s. Then what is S1? xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c. Here g into 2x, 2x is expressed as x plus x, 1x is changed to x1. Similarly 2y is written as y plus y, 1y is changed to y1. Here this is x into x, 1x is changed to x1, similarly here. In the same way, here y square becomes y into y becomes y into y1. This is 2a into x plus x. We can write as S1 is 2a into x plus x1. You can easily understand. S11, it is not S11, it is S11. By changing both the y's and both the x's to y1 and x1, we get this one as y1 square minus 4ax1. That means by substituting a point x1 comma y1 in this equation, the value obtained is S11. In circle, S11 is called power of the point with respect to the circle, but in parabola there is no such name, just it is S11, it's an expression. In formulae, whenever you get this, you can represent it by S11. S2, if you observe S1, you can write S2, y2 minus 2a into x plus x2. Next, S12, change 1y to y1, 1y to y2, 1x to x1, 1x to x2. Then you will get y1, y2 minus 2a into x1 plus x2. Okay. Parametric coordinates, we have already discussed about this in the last class. The parametric equations of y square is equal to 4ax or x is equal to at square, y is equal to 2at. By eliminating t from the equations, we get y square is equal to 4ax only. So, these two are called parametric equations of the parabola y square is equal to 4ax, where t is a parameter. So, if you take the point at square comma 2at, it always lies on the parabola for any value of t. So, this is called parametric point. Suppose point is p at square to at. In further classes, we are going to write it as p of t, means point p in which parameter is t. Okay. So, you have to understand p of t as p of at square to at. Similarly, for x square is equal to 4ay, the parametric coordinates are 2at comma at square. If it is y minus k whole square is equal to 4a into x minus h, then add h and k to the coordinates. These are the parametric equations. Similarly, for x minus h whole square is equal to 4a into y minus k, adding h and k to this, you will get parametric coordinates. Okay. So, in further classes, we are going to write parametric point as p of t. So, if this is p for this parabola, p of t means this point. Now, let us start problems after discussing few more theory points. Position of a point, with respect to a parabola. Let us take the parabola y square is equal to 4ax. Its focus is a comma 0. Directrix is x plus a is equal to 0. If a point p x1 y1 lies on the parabola, then we know that SP is equal to PM, where PM is perpendicular on the directrix. So, for point on the parabola, SP will be equal to PM. For point inside the parabola, if a point P is inside the parabola, then SP will be clearly less than PM. For interior points, if a point P is outside the parabola, then this is SP, it will be more than PM. So, for points exterior to the parabola, SP is greater than PM. But what is an interior point and what is an exterior point? What is the interior region? What is the exterior region? We have to define, because it is not a closed curve, it is an open curve. We define the region containing the focus as interior region. Okay. The parabola divides the whole xy plane into two regions, this and this. The region containing the focus is interior region, the other region is exterior region. Okay. So, if a point is here, we say that point is inside the parabola. If a point is here, it is outside the parabola. Now, if SP is equal to PM, we get SP square is equal to PM square, or SP square minus PM square is 0. Let us simplify. What is SP square minus PM square? SP square is x1 minus 0 x1 minus a whole square plus y1 square minus PM square. What is this PM? This part is x1, this is a. So, PM is x1 plus a minus of x1 plus a whole square should be equal to 0. What is this? It is y1 square minus this plus this is 4ax1. A plus b whole square minus a minus b whole square is 4ab now. So, it is y1 square minus 4ax1 is equal to 0. According to our standard notation, this is S11. So, S11 is equal to 0 for points on the parabola. If you take SP is less than PM, then SP square minus PM square will be less than 0. So, S11 will be less than 0 for which points? For points lying inside the parabola, S11 is negative. If a point P lies outside the parabola, then S11 is greater than 0. So, if you want to know the position of a point with respect to the parabola, then find S11 by substituting the point in the equation. If the value is positive, point is outside. If the value is negative, point is inside. If the value is 0, then point is on the parabola. Okay? Now, let us begin the problems. The same points. The region containing the focus of a conic is the interior region, not only for parabola, it is for any conic. In ellipse, there is no confusion because it is a closed curve. But in hyperbola, again we will have confusion. Hyperbola will have two branches. For open curves, this is the definition. Point, the region containing the focus is interior region. Okay. If S11 is negative, then point is inside the parabola. If S11 is equal to 0, point is on the parabola. If S11 is greater than 0, then point P lies outside the parabola. So, these are the points in the theory. Now, we will begin the problems. After solving problems on this theory, discussed theory, we will proceed to further theory. First question, find the focus, vertex, directrix and the length of the lattice rectum of the parabola y square minus plus 4x minus 6y plus 13 is equal to 0. Focus, vertex, directrix, length of the lattice rectum, all these are called characteristics of the parabola. So, simply the question can be asked as find the characteristics of the parabola. Now, clearly this can be expressed as x is equal to quadratic in y. So, first you have to identify that it is a parabola having axis parallel to x axis. Okay. If the axis is parallel to x axis, the standard form of the parabola is y minus k whole square is equal to 4a into x minus h. If the axis is parallel to x axis, equation of the parabola will be like this. It may be plus 4a or minus 4a depending on the concavity. So, first we reduce this into this form. How to reduce? Take first second degree term and first degree term of y. You write it as a perfect square in y. Y square minus 6y, by adding which number it will become y minus k whole square. This is y square minus 2 into 3y. If you add 3 square, it becomes y minus 3 whole square. So, you have to subtract 3 square, remaining term is 4x and plus 13. Already we have added 9 here, so 13 minus 9 will be 4. Now, first 3 terms can be written as y minus 3 whole square is equal to, taking these two to right hand side, we get minus 4 into x plus 1. Now, it is exactly in this form. Then immediately you can write vertex. What is the vertex? H comma k for this parabola, and vertex of this parabola will be minus 1 comma 3. Vertex is over. Next, what else can we identify? We can identify 4a. 4a is 4. So, a is equal to 1. If a is equal to 1, we can find length of the lattice rectum. Length of the lattice rectum of this parabola is 4a. A is equal to 4. Now, we have to find the focus and directrix. We have discussed in the theory what is the focus of this parabola. Now, we have to take minus, we got minus sign now. So, I will take it as minus. What is the focus? If you forget, recollect y square is equal to minus 4ax. For y square is equal to minus 4ax, the focus is minus a comma 0. Add h and k, it becomes minus a plus h comma k. So, now I am going to write focus is minus a plus h comma k, that is minus 1 plus minus 1. Minus 1 plus minus 1 is minus 2. Plus comma k, k is 3. So, focus is minus 2 comma 3. Next, what is the next? Directrix. Directrix of this parabola y square is equal to minus 4ax is x minus a is equal to 0. Directrix of y square is equal to minus 4ax. Now, directrix of this parabola will be given by replacing x by x minus h. It will be x minus h minus a is equal to 0. What is x minus h minus a? X minus of minus 1, that is x plus 1, minus a means minus 1 is equal to 0, which is x is equal to 0. Directrix is x is equal to 0 or y axis. Similarly, if you take the equation of the parabola in the form of x square plus some constant into a, some constant a into x, bx plus ax plus by plus c is equal to 0. If the parabola is in this form, then immediately write it in the form of x minus h whole square is equal to 4a into y minus k, and comparing the coefficients you find h, k and a, then find the characteristics. Next question. If an equilateral triangle is inscribed in the triangle y square in the parabola, if an equilateral triangle is inscribed in a parabola, y square is equal to 4ax with one vertex at the origin, find the length of the side of the triangle. It is a nice question. The parabola y square is equal to 4ax will be this. Now we have to inscribe a triangle, an equilateral triangle. How? With one vertex at the origin. Inscribing a triangle in a parabola means we have to take all three vertices on the parabola. One vertex is fixed at origin. This is one vertex. Now, if you take one more vertex here, you will get another vertex here. The equilateral triangle will be like this. Its one side will be definitely perpendicular to the axis of the parabola. So, let this be the equilateral triangle inscribed in the parabola. Let the length of the side be L. This is L. This total length is L. Then this is L by 2. This is L by 2. Then how to find L? We know that this total angle is 60 degrees. So, this angle is 30 degrees. Is it not? Then if this is L, this angle is 30, what is this adjacent side? It will be L cos 30 degrees. Opposite side will be L sin 30 degrees, that is L by 2 only. If this is L, this is 30, this is L cos 30. What is L cos 30? L root 3 by 2. Opposite side will be L sin 60, that is L into 1 by 2, L by 2. So, the coordinates of this point will be x coordinate L root 3 by 2, y coordinate L by 2. This point lies on the parabola y square is equal to 4ax. So, substitute y square means L by 2 whole square is equal to 4ax. 4a into x is L root 3 by 2. You can cancel L on both sides and 1 2 also. So, you will get L by 2 is equal to 4a root 3. Then what is L? 8a root 3. We want the length of the side of the triangle now. Answer is 8a root 3. Next question. Find the equation of the parabola passing through the points 1 comma 2, 2 comma minus 1, 0 comma minus 3 and axis and having axis parallel to x axis. I will take now y axis. We can take x axis also, no problem, but I am taking y axis. If the axis of the parabola is parallel to y axis, we know that the parabola will be either like this or like this. In both the cases, the general equation of the parabola is y is equal to ax square plus bx plus c. If the axis is parallel to y axis, we can directly assume that the equation of the parabola is y is equal to ax square plus bx plus c. So, let y is equal to ax square plus bx plus c be the parabola. Then it passes through 1, 2, 2 minus 1, 0 minus 3. Substitute 1 by 1, 2 is equal to a plus b plus c. Substituting first point, substitute second point, minus 1 is equal to 4a plus 2b plus c. Substitute the next point, minus 3 is equal to c. Then first equation becomes a plus b is equal to 5. Second equation becomes 4a plus 2b is equal to 2, or dividing by 2, 2a plus b is equal to 1. Now solving this and this, directly subtracting, we get a is equal to minus 4, then b is equal to 9. So what is the equation of the parabola? Therefore, the parabola is y is equal to minus 4x square plus 9x minus 3. Okay. It is a downward parabola, parabola of this shape. Next question, an arch is in the shape of a parabola, its width across the road is its width across the road is 10 feet. A vehicle of width 6 feet and height 8 feet will be just able to pass through it. Then find the height of the arch at 1 foot above from one end. Let us assume that the arch is like this, a parabolic arch. This is the road level, this is the road, this is the arch. What is given? Its width across the road is 10 feet. This is 10 feet. What else? A vehicle of width 6 feet and height 8 feet will be just able to pass through it. Say this is a vehicle of width 6 feet and height 8 feet. It will be just able to pass through it, means this corner and this corner will just touch the parabola. Then what do you want? Find the height of the arch at 1 foot from one end. Let us take this end at a distance of 1 foot from one end. we want the height of the arch, this height, this is the required value, required height. What we do is, we assume that this is a standard parabola, but it is a downward parabola, no? So, let us assume that this is origin and let this be x axis and this be negative y axis, negative y axis y dash. What is the equation of the standard parabola having vertex at origin and concavity downwards? Just now we have discussed, it is x square is equal to minus 4ay. Let the parabola be x square is equal to minus 4ay. A is always positive. Now, let the height of the arch be h. Let height of the arch be, let height of the arch above the ground level, above the road level be h. Then what will be the coordinates of this point? Coordinates of this point, x coordinate will be 5, total width is 10 and this parabola is symmetric about its axis. So, this will be 5, this will be 5. Okay. So, x coordinate is 5 and y coordinate is what? H, but it is downwards. So, minus h. Okay. 5 comma minus h lies on the parabola, x square is equal to 4ay minus 4ay. So, substituting substituting 5 comma minus h. What will get? 25 is equal to 4ah. This is one equation. Next, for here we do not know h and a. So, we need both a and h to find out the answer. Now, let us take this point. This point is, what is the x coordinate? This total width is 6, so this is 3. So, x coordinate is 3. X coordinate is 3 and y coordinate is what? This much. What is this? This total is h, this is 8. So, this is h minus 8 with negative sign because it is negative direction of the y axis. So, it will be 8 minus h. This point also lies on the parabola x square is equal to minus 4ah. Substituting three comma 8 minus h, you will get 3 square 9 is equal to minus 4a into 8 minus h. It is 9 is equal to minus 32a plus 4ah. Already we have calculated 4ah, substitute it. It is minus 32a plus 25. 4ah is 25, no? So, we will get 32a is equal to how much? 25 minus 9, 16. We get A is equal to 1 by 2. Then what is H? H is equal to, if A is equal to 1 by 2, 2H is equal to 25, H is equal to 25 by 2. Now finally, we are going to calculate this height. Let us assume that this height is some K. K is not there now in the question. I am taking this height as K. Then what will be the coordinates of this point? This is 1 foot. This total length is 5 feet. So this must be 4. So x coordinate is 4 and y coordinate is what? This total is h. This is k. So this is h minus k with negative sign. It will be k minus h. Substitute it. Substituting this point in the equation x square is equal to minus 4ah, x square is 16 is equal to minus 4a into k minus h will be 4a into h minus k. 4ah is how much? 25 minus 4a into k, substituting a is equal to 1 by 2. It will be 25 minus 2k. So finally, you will get k is equal to 9 by 2 feet. So height of the arch at 1 foot from one end is 9 by 2 feet. Next question. Find the locus of the vertices of the family of parabolas y is equal to a cube x square by 3 plus a square x by 2 minus 2a. Here it is a parabola. If a is fixed, it is a fixed parabola. It will have fixed focus, fixed vertex. The question is find the locus of the vertex of the parabola, means vertex is moving, that means parabola is variable. As a varies, the parabola also varies, then focus vertex also varies, and all the vertices will follow a path. We are going to find that path. It is a parabola of the form y is equal to quadratic in x. It is what kind of parabola? It is a parabola having axis parallel to y axis. How to find the vertex of that parabola? We have seen in the previous question. We have to convert that equation into this form: x minus h whole square is equal to plus or minus 4a into y minus k. We have to write that equation in this form. For that, first you divide by a cube by 3 on both sides, then you will get 3y by a cube is equal to x square plus dividing by a cube by 3, no, you will get 3x by 2a plus 3x by 2a minus dividing by a cube by 3. So you will get 6 by a square, because 2a by a cube by 3, 6 by a square. Now how to convert into this standard form? By making this a perfect square. To make this perfect square, we will write it as x square plus 2 into 3 by 4a into x in the form of a square plus 2ab. Now, by adding 3 by 2a whole square, it becomes 9 by 16a square. It becomes a perfect square. But if you add 9 by 16a square, you have to subtract minus 9 by 16a square minus 6 by a square. Then these three terms will form a perfect square. X plus 3 by 2a whole square is equal to, take all those terms this side, combine these two first, 16a square LCM LCM of 16a square and a square is 16a square. Here 9 plus 96. Okay. Then it is 105 by 16a square. So, you will get 3y by a cube plus it is 105 only, no? 105 by 16 a square. Now, you write it in this form exactly, x plus 3 by 2a whole square is equal to, for writing it in this form, take a 3 by a cube common. 3 by a cube into y plus, we have to multiply by a cube by 3. 105 by 16 into a cube by 3 means a square cancels, by a into a by 3, it is 35a by 16. Now, what is the vertex comparing with the above? Vertex denoted by A is equal to h comma k. H is minus 3a by 3 by 2a, comma k. K is minus of 35a by 16. As A varies, what is the locus of A? Take this as x comma y. Now, we have to get a relation between x and y independent of A. You can easily observe that x into y is independent of A. So, we get xy is equal to, what is the product? 105 by 32. Okay. So, the locus of the vertex A is xy is equal to 105 by 32. This is the answer. Okay. But in this question, we have converted into standard form, but it is better to remember a formula for vertex of the parabola whose axis is parallel to y axis. I will give it. If a parabola is like this, its general equation is y is equal to ax square plus bx plus c. At bottommost point, you know that derivative is 0. If you take dy by dx is equal to 0, you will get x coordinate as minus b by 2a, and this is the minimum value of this quadratic function. All of you remember the formula for minimum value of a quadratic expression, that is 4ac minus b square by 4a. So, if you remember this formula, you can directly find this point using that formula, no need of working like this. Similarly, even when the parabola is like this, the same formula will be valid for vertex. Okay? So, next question is bit long, now time is not enough, so I will check for an easy question. Yeah, this question is some easy question, only one and a half minute left. A point A is given 6, 2. Find the point P on the parabola y square is equal to 12x such that SP plus PA is minimum. Let us first draw the diagram. This is our parabola. How is this parabola? Its vertex is origin, length of the latus rectum is 4a, that is 12, and the y axis will be tangent at vertex. I will draw it properly. Now 6, 2, where is the point 6, 2? How to know whether it is inside or outside or on the parabola? Substitute 6, 2 in the equation y square minus 12x is equal to 0. It may be 0 or may not be 0. Substitute the point 6, 2 in y square minus 4ax. Y square is 4 minus 72, negative. So, point 6, 2 is inside the parabola. So, I will take it here. Now, I want the point P on the parabola such that SP plus PA is minimum. But what is S in the usual notation? S is the focus. Let this be the focus. All of you are aware of the formula for focus of the parabola y square is equal to 4ax, that is a comma 0. What is a here? 3. So, this is 3 comma 0. Now, we want this point P such that SP plus PA is minimum. You have the property of the parabola that SP is equal to PM. Any point P will be equidistant from the focus and directrix. So, instead of SP, we can take PM. SP plus PA should be minimum. I will take PM instead of SP. Now, PM plus PA should be minimum. Where is PM? You draw the directrix. This is the directrix. PM is perpendicular distance from P to the directrix. This is PM. Now, PM plus PA should be minimum. So, you can easily see what should be the point P. This will be minimum when the 3 points are collinear. So, the diagram should be like this. Then only SP plus PM, MP plus PA will be minimum. So, SP plus PA will be minimum. Then how to get point P? Find the equation of this line. Clearly, this is a line through 6, 2 parallel to x axis. What is this line? Y is equal to 2, this line. solving with the parabola, solving y is equal to 2 and the parabola y square is equal to 12x, you will get 4 is equal to 12x, x is equal to 1 by 3. So, the required point P is 1 by 3 comma 2. Okay, with this we are going to close the session, and we are going to continue this chapter in the next class with more properties about a parabola, and we are going to discuss about tangent of a parabola in the next class. Okay, we are going to meet in the next class with discussion on tangent of a parabola. Okay, thanks for watching, see you.